better watching than listening sometimes. So, all right, so we're going to talk multiplying polynomials. And you've been doing this for a long time. You just didn't call it that, okay? When we were doing problems, it looked like this. What property were we using? Distributive property. Remember that you multiply 8 times both pieces on the inside. That's what multiplying polynomials is. It's just distributive property. We're going to build up to where it's distributive property more than once in a problem, but it's just distributive property. So I want you to understand that it's not anything really new happening here. It's something you've been doing for years. You just didn't call it polynomials. You called it multiplying by distributive property. Okay. Now, with polynomials, we call them polynomials, and we haven't talked about naming them yet, like by how many terms they have. So what we've got here, 8 is called a monomial because it's just one singular thing, and the prefix mono means one. Mono means one. So 8 is a monomial. This one has 2 terms. What do you think it's called? What's the prefix for 2? You learn to ride something when you're younger. Has 2 wheels. Well, a tricycle has 3 wheels, right? Bicycle has 2 wheels. Bi is the prefix for 2. This is a binomial because it has 2 terms. Okay, doesn't really matter what you call it out of that, but we're going to kind of start working our way toward some of those terms as we're doing this stuff. Monomial, 1 term. 2 terms is a binomial. 3 terms, like Logan said, is a tricycle has 3 wheels, so 3 terms is going to be called a trinomial out of that. So we're going to you're going to hear me using those words, so I don't want you getting lost in those words. It just means how many terms does it have out of that. So distributive property on this says you take 8 and you multiply it times 3x, and then 8 times the minus 7. So what's 8 times 3x? 24x. And what's 8 times negative 7? 56. 8 times 8 is 64. 8 times 7 is 56. Okay? That's it. That's all you're doing on that problem, is you're distributing it. And the reason you're done is because, are these like terms? No, they're not like terms, so you can't put them together. So that's it. That one is easy. It gets harder, no doubt. You guys know that. It's not anything new here. So let's say we had something like this. Let's say we had 2x parentheses 5x minus 3. So here we have a monomial, 2x, because it's just one piece, times a binomial again. So it's the same kind of problem as this, but it's got letters in it. Okay? So when we distribute, we're distributing 2x to both pieces, not just 2. So what's 2x times 5x? 10x. What's the exponent on these x's up here? They're both 1s. What's the rule about what do you do with exponents when you multiply? Add them. So what's 1 plus 1? So that's x squared. X times x gives me x squared, right? All right. Then we got to distribute 2x to the minus 3. Be negative 6x, because this front piece has an x, it goes out there too. Are these like terms? No, this one has x squared, this one has plain x. They can't be put together any further, so that means, guess what? You're done. Let's try another one of those. 6x parentheses 5x plus 2. See if we can do that one. It's a lot like example B. Thanks. So 6x is multiplying to both pieces on the inside. What's 6x times 5x? 30x to the second power, or x squared. And then 6x times the 2. 12x. And it should be a plus or a minus in between those. Why is it plus and not minus? There's no negatives. They're both positive, right? So it's positive times positive, still positive. So that's the plus. Guess what? You're done. All right. Not too bad. Let's get another one. Let's say we had negative 4x squared times 10x minus. Let's just do 12. Take the x off of it. That'll be work. That'll work fine. Still a monomial times a binomial is what we're doing here. So distributive property, that's all this is. We're distributing negative 4x squared to both pieces. Negative 40 x to the third power this time because we have 2 plus 1 out of that. And then we have negative 4x squared times a minus 12. Negative 4 times negative 12 is negative times negative is a positive 48 x squared. Got to watch your signs. Negative times negative is going to turn into a positive. And then the x squared goes with it. And distributes across there. Okay. Distributive property. That's what we're doing a lot of today. Let's get to know example E. Let's say we had 5x parentheses 10x squared minus 3x plus 8. We have a monomial times, what would you call this? A trinomial because it's got 3 pieces. Okay. So what property are we using? Multiplying by distributive property. That's all we're doing here. So 5x times 10x squared. 50x to the third. The next piece. Plus or minus between those. Why is it a minus and not a plus? 5 times negative 3 is a negative 15. So that's where it's a minus at. 5x times 8. Plus or minus? Plus because it's positive. And 40, and that 40 has what? An x on it. Don't forget. We're done because there's no like terms there. There are not any like terms to combine. We're looking for things that have the same variable, same exponent on them to combine them if that happens. Okay. So distributive property. There's one thing in front, you distribute that one thing to everybody that's in the parentheses. Okay. Let's look at one that, let's just throw a fraction in there. 2/3 x squared, parentheses 12x squared minus 6x plus 9. I picked good numbers, so this works out nice. But idea here is that fractions are just numbers. We're just working with numbers. What property is this still using? It's a trinomial times a monomial using distributive property, right? Multiplying across there. So 2/3 x squared goes to everybody. So 2/3 of 12. 8 x to the 4th power. Good, Aubrey. And then 2/3 of negative 6. 4x to the, how much power? Third, because we got squared and 1. So that's a third. Is that a plus or a minus between those? Minus because we have positive times negative, and that's a negative answer. And then 2/3 of 9 be 6. Anything else with that? Plus sign, and it's just a plain x. It's x squared. Because what we were distributing had an x squared on it. So that last piece you got to have. And you're done. There's no like terms, so you can't put anything else together. Okay, so it's distributed property. So if there's a monomial, one thing in front, you distribute it to everything in the inside. Okay, work it out. That's multiplying by a monomial. Let's look at the next step in work here is taking x minus 4 times 3x plus 2. Okay. How many things are in this? 2 of them. So that means we're going to do distributive property how many times? Twice. 2 times. Okay. So we're going to distribute x to everybody. X times 3x is 3x squared. X times positive 2, so plus 2x. Okay, that's one distributed property. Remember we said this has got 2 terms, so we're going to do it twice. So we're going to distribute this negative 4 to everything over here. What's negative 4 times 3x? Negative 12x. What's negative 4 times positive 2? Negative 8. Are we done? Why not on this one? We got some like terms in the middle there, so we got to combine those. Okay, so we got 3x squared. What's positive 2x minus 12x? Negative 10x, and then the minus 8. Now we're done. Okay, so it's just distributive property twice when we got 2 things in the front. That's all we're really doing there. Okay, let's do another one. H. So we had x plus 3 times 6x minus 5. Okay, so first one is 6x to the second. Good. Negative 5x. Good. 3 times 6x would be 18x. Tyler's on task here. He's got it. 3 times negative 5. Negative 15, right? Like terms, where they at? In the middle there, we got the negative 5x and a positive 18x. 6x squared plus what? Not negative 13. Which one's bigger, the 18 or the 5? 18, so the answer's got to be positive. So it would be positive 13x and then minus 15. Notice the order that I'm writing the answer in. Biggest exponent and then go down. That's called descending order, and that's the order you want to get used to putting it in out of that, because that's what's called standard form when you do that. Okay. Let's go to one that it's the same stuff, but maybe it's a little bit harder. 4x minus 1, 3x plus 5. We got more numbers in it. So we're distributing 2 times. 4x goes to both of those. So that'd be 12x squared plus 20x. And distribute the minus 1. So negative 1 times 3x is negative 3x. Negative 1 times 5, negative 5. Like terms. (20) in the 3x, so 12x squared plus, nope, 20 minus 3 is 17x. Okay. So binomial, 2 terms, times a binomial, 2 terms. It's just distributed property twice. That's all it is. Okay. Now, go on the next one. Let's say we had something like this, x plus 5 times 2x squared minus 3x plus 7. Okay? So we have a binomial times a trinomial. Okay, so how many distributed properties am I doing though? Well, technically I'm distributing x and 5, so it's really only 2, but it's 2, 3 things at a time. So x times 2x squared would be 2x to the third minus 3x squared plus 7x, right? And then distribute the 5 to all 3 pieces. So it'd be plus 10x squared minus 15x plus 35. Now this one's got more like terms to go together, right? Is there anything like a 2x cubed? Is there any other pieces that have x cubed? No, so I'm just going to write that one down. 2x to the third. Negative 3x squared. Any other x squareds? Yeah, I got this positive 10 here. So negative 3 plus 10, 7x squared. 7x. A negative 15x. So what's positive 7 minus 15? Negative 8x. Then the 35 is the only thing left over. And it doesn't have any like terms, so you're done. It's not that bad. It's just distributed property. You just got to know how many times to do it. And how many terms are in the thing in front? Just distribute all of them. And then simplify. That's really all this is doing that. If you had something even larger, we'll do another one here. Let's say we had, we're not going to do one that big. Let's say we had something like 3x squared plus 7x plus 2 times negative 3, or let's do negative 4x squared minus x plus 5. How many distributive properties do I have to do? 3 of them. 1, 2, 3. 3 of them. That's how you decide. So 3x times everybody over here, or 3x squared times everybody over there. Be negative 12x to the squared and squared makes 4. 3x squared times negative x would be negative 3x to the third. 2 and 1. So it's third. 3x squared times 5 is 15x squared. Okay, and then we're going to distribute the 7x to everybody. I'll just use a different color here. 7x times negative 4x squared. Negative 28x to the third. 7x times negative x. Negative 7x squared. 7x times 5. 35x. Then I got to distribute the 2. That's the easy part because it just doubles everything. So that's negative 8x squared, negative 2x, and positive 10. A lot of like terms here to deal with. Is there anybody else that has an x to the 4th? No. So I'm just going to copy that one down. Negative 12x to the 4th. Does anybody else have x cubes? Yeah, we got this one and this one. So that's negative 3x cubed, and negative 28x cubed would be negative 31x cubed. So maybe it helps to mark them out as you use them. Maybe that makes it a little easier on you. You don't have to, but yeah, it might, when it gets really long, sometimes it's easier to mark them out after you use it. So we got a 15x squared. Y'all go to lunch. We'll finish. Thanks, Logan.